Why are friction and heat loss considered irreversible processes? Imagine pushing a box across the floor. You feel resistance and some of your energy turns into heat. That heat doesn't just stay with the box, it spreads out. Now, think about what happens when that heat dissipates into the surroundings. It's a one-way street. This is a good way to see why friction and heat loss are called irreversible processes. They involve energy changes that can't be completely undone. When you push the box, some energy is lost as heat. Even if you try to move the box back, the heat has already spread out and mixed with the environment. You can't just reverse the process and get all the energy back in the original form. This ties into the idea of entropy, which measures how disordered or spread out energy is. When energy disperses as heat, entropy increases. That increase makes the process irreversible. A reversible process is like a perfect, imaginary scenario where you can undo everything with a tiny change. For example, slowly pushing the box so no heat is lost and no energy is wasted. But in real life, friction always converts some mechanical energy into heat. This heat escapes into the surroundings and can't be recovered. So, even if you stop and try to reverse the movement, the energy has already dispersed. That's why friction is a classic example of an irreversible process. It causes energy to spread out, increasing entropy, and making it impossible to return everything to its original state without extra work. Heat loss works the same way. When heat moves from a hot object to a cold one, it naturally flows in that direction. This spontaneous flow increases the total entropy of the system and environment. To reverse it, you would need to put in energy, like running a heat pump, to move heat back against its natural flow. But this process consumes energy and doesn't restore the original conditions without additional effort. That's why heat loss is considered irreversible. It's a one-way transfer that increases disorder and can't be perfectly undone. In real machines and engines, these effects mean some energy is always lost. Friction in moving parts causes energy to turn into heat, reducing efficiency. Heat escaping from the system also wastes useful energy. Engineers work hard to minimize these losses, but they can never eliminate them entirely. Understanding why friction and heat loss are irreversible helps us see why no machine can be perfectly efficient. It's all about how energy naturally spreads out and increases disorder, making it impossible to revert everything to its starting point without extra input. This idea is a key part of the second law of thermodynamics, which explains why natural processes tend to move toward more disorder and why some energy always disperses.